Okay, hello. Today we're going to do something a little bit more tricky. Today we are going to be building a pie chart from scratch. So, in order to do that, we're going to have to start with a table. Well, we asked a survey of students what was their favorite sport, and those students gave us the following answers. This is what we're going to put into our chart. So let me back this up a little bit so we can see the whole thing. We're just going to start here, and we're going to have, well, I'm going to write in here, let's make it a bit bigger just so we can work with it. My writing's not that clean. So, the top of this table, I am just going to write sport. We asked students out of 1, 2, 3, 4, and at the bottom we'll have total. Out of these 4 sports, what is your favorite? The options were, let's say, hockey, football, soccer, and baseball. So those were the 4 choices for the survey. And let's say when we tallied all of our students together, let's say 14 of them chose hockey, 6 of them chose football, 5 of them chose soccer, and 5 of them chose baseball. So this is our data set. Doesn't really matter. I made this up on the spot. The important thing to note is that these are qualitative points of data. You know, we asked what's your favorite sport out of these 4, and they answered hockey or they answered football. This is qualitative data, not quantitative data. Pie charts are really good for displaying qualitative data. They're not so good for displaying anything else, but they do a really, really good job of displaying qualitative. So that's why we're learning them today. So we've got our sport category, and we cannot forget that the last one is reserved for total. And then over here, I'm going to call this real data. Sometimes you'll see it's called frequency, but we just want to know that it's the actual count. Real data. It's the actual count of, how many students liked these sports. If you were doing this from scratch, then maybe as you were doing the survey, you'd actually be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You might actually have the ticks in here. You could do that right there, but we're just going to pretend that I did my survey elsewhere and I just came up with all this data here. Now, beside our total, we have our individual. 14 people liked hockey, 6 people liked football, 5 people liked soccer, 5 people liked baseball. We cannot forget to do our total. So let's add them up. We can use our calculator, we can use our head, but we'll double check with our calculator. 14 plus 6 plus 5 plus 5 gives us 30. We have a total of 30. Okay, so we are well on our way to making our pie chart, but we've got 2 steps before we actually get there. So we have our sport column, we have our real data column. Now we're going to move over, and I want to find, in this next column, what proportion of the whole, it's going to let me do the pen, what proportion of the whole, or what percent of the whole, rather, is each sport. So, what percent of the whole does each sport represent? For this, we're going to have to use some fractions. So we know that our whole is going to be 30 votes. So these are all going to be a fraction out of 30. For instance, another way of phrasing this, 14 out of 30 students liked hockey best, whereas 6 out of 30 students liked, what sport was this? I should zoom out so I can see my full data set. Liked football best. 6 out of 30 students liked football best. 5 out of 30 students liked soccer best, and 5 out of 30 students liked baseball best. Now these are a fraction. These are not a percentage, not yet, but we know how to turn a fraction into a percentage. We take the numerator, divide it by the denominator, and multiply it by 100. So here I'm going to do 14 divided by 30 times 100. 14 divided by 30 times 100. This is going to give me 46.6%. We're going to round it to the nearest percent. So 47%. So what this is telling me is 40% of the students that 47% of the students that we surveyed liked hockey best. Let's see how many liked football best. It's going to be 6 divided by 30 times 100. So I'm taking 6 divided by 30 times 100. What percentage of students did we survey liked football best? 20%, right on the nose. I like it. 20%. And how do we find the percentage of students who we surveyed who liked soccer best? Well, it would be 5 out of 30. To turn that into a percent, we're going to do 5 divided by 30 times 100. 5 divided by 30 times 100. That gives me 16.6 repeated percent. We're going to round that to the nearest whole, 17%. And we're lucky that, these two data sets are the same. 5 students liked soccer, 17%. 5 students liked baseball. We don't need to do the math again, 17%. Now, our total, 30, we could do it. I mean, we know that the total is always going to be 100% because that's the total of any percentage, but we could just represent it as a fraction first, and we could just prove to ourselves 30 divided by 30 times 100. Look at that, it's 100%. I guess it's worth checking, but it will always be 100%. Your total will always be 100%. So now we have these down to the proportions as percentages. 47% of students chose hockey. 20% of students chose football. 17% of students chose soccer, and 17% of students chose baseball. The last step we need to do before we're ready to actually turn this into a pie chart is turn these into degrees, because we know a pie chart is made of a circle. I can even zoom out and show you where we're going next. We've got our circle ready to go. But because a pie chart is made of a circle, we're going to have to convert these percentages into degrees, because degrees are essentially like the language of a circle. There are 360 degrees inside any circle. 360 degrees. That's why when you jump in the air and you spin around and you land facing the same way, you do a circle in the air, you say you did a 360. You traveled 360 degrees. So that tells me my total, if my new column is degrees, I'm going to switch to my pen. My new column is degrees. And my new total is going to be 360 degrees. So now we need to convert these percentages into degrees. Not so hard, not as hard as it looks. In order to do that, we need to find out what each percent of 360 each of these is going to represent. So, in other words, for hockey, what is 47% of 360? 47% of 360. That will tell me how many degrees I need to represent it as on my pie chart. Now, this will sound more clear when we actually get down to drawing our pie chart. Trust me. For now, just like when we're calculating tax or a discount or something like that, we're just going to use multiplication to find out what is 47% of 360. And to do that, we multiply the whole number, 360, by the decimal version of the percent. So what's the decimal version of 47%? Well, we remember from our previous lessons, the decimal version of 47% is 0.47. 0.47. That is going to give us 47%, or 14 out of 30, in degrees. So what is 47% of 360? I'm going to do it on my calculator. 360 times 0.47. 169.2. I'm going to round that to the nearest whole. I'm going to call it 169 degrees. Now, I've showed all my work here. You don't have to show me that you're doing 360 times 0.47. I'm going to assume that you know how to do that when you're actually filling out your own chart. You can just skip straight to that 169 degrees. just like I'm going to do here. So for football, we know football was 20%. 20%. So what's 20% of 360? I'm going to take the whole number, 360. I'm going to times it, multiply by the decimal version of the percent. What's the decimal version of 20%? 0.2 or 0.20. Both are the same. 72 degrees. So 20% represented by football, 6 votes out of 30, 20%, 72 degrees. Now don't worry if this doesn't mean anything to you. You'll see how we use this in a sec. Let's get soccer and baseball, and then we can put this all together. So 17%, what's 17% of 360 degrees? Well, I'm going to do my whole number, 360. Oh, for some reason that's 4,360. Let's do 360 times the decimal version of the percent. What's the decimal version of 17%? 0.17. 61.2. Let's round it to the nearest whole. 61 degrees. And these are both 17%. So I know if this is 61 degrees, so is this. It's the same number. Okay. So if I add all these up together, they should add up to 360. Now we might be off by 1 just because we rounded some of those numbers. That's okay. We don't have to be ultra precise, but they should round up. Sorry, they should add up to 360 if we didn't round our numbers. Let's just prove it to ourselves just so we can see that math. 169 degrees plus 72 plus 61 plus 61. What does that give us? 363. So that extra 3 is nothing to worry about here. It just comes from the fact that we rounded the 169, we rounded this 61, and we rounded this 61. So we ended up with a slightly askew number. It's not going to mess with our pie chart. 3 degrees off, we don't have to be that precise. We are within the range. That's reasonable. And if we didn't do any of that rounding, if we kept all of those decimals, it would have rounded, or it would have added up perfectly to 360 degrees. So I'm not worried about that extra 3. That will be fine. Now, let's go look at our circle. I'm going to bring it up. And I want those numbers to be in view, so let's see if I can actually move that circle. I wonder if I can. Is it going to let me? Here we go. Yep. Let's move this circle. Okay. I'll move it up. And you can see I have a protractor ready to go. So when you're doing this by hand, that is a really important tool to have on hand here. A protractor, it's how you are going to measure your degrees. So let's move this up so we can use it as well. And I will zoom in. Okay, so I've got my protractor, I've got my circle. Now, you might be wondering, is there anything special about this circle? No, this is just a circle that you would have drawn on your page. Maybe you'll have some tool to make it. I usually use a protractor. I just trace the outside of the protractor, I flip it, I trace the opposite, and then I have a perfect circle to work with. I would probably recommend doing the same, just so everything lines up and is pretty precise. Now we can actually get started. So we're going to put a center point on our circle. I can do that just by lining it up here. You can do that just by using your eyeball. It doesn't need to be, computer perfect. We've got a center point, and then we're actually just going to draw a line to the outside. So we can start off with a free line. I'm going to do it as straight as possible. I would love for you to use a ruler or the bottom of your protractor. I can't do that on my computer, so I'm just going to, I'll just do that first one. You can see I'm not super precise. That'll have to do. Okay, we've got our original line, and we are going to line up our protractor perfectly on that. Oh, it thinks that it's, no, let me fix that. Sorry, guys. I'm going to get this protractor out of the way, and I'm just going to eyeball a center circle. Sorry for the technical difficulties. And then I am going to do my best just to draw a line exactly where I need it to go. I've got a tool for that. Let's use the tool. Let's use what this computer is giving me. So I've got a line from the center out. That's my free line. I'm starting off with it. I'm going to use this protractor. I'm going to align it with that center line. I want the 0 to go exactly there. exactly on that bottom line. You can see I'm having some technical difficulties. It doesn't quite want me. It keeps snapping me where I don't want it to be. Let's see if I can figure that out. Give me 1 second. Okay, unfortunately, I paused the video to see if I could turn off this snap feature, but apparently it is written into this program, so we're forced to keep it. I'm very sorry about that. It will get a little bit in the way of what I'm trying to do, but I think we can get there. I think we can get there all the same. So, we have started off with our circle, our regular old circle, and we have a vertex in the middle of it with a single line that we drew out. We'll recognize this as a radius. Now I want to put our protractor right on this line, and what my computer is going to do, because it's desperate to snap on and get in the way, it's going to put the very bottom of the protractor right on that line. What I want you to do, and it's frustrating me that it's not going to let me do this because it's important that you know, but what I want you to do, I want to take your protractor and I want you to align this black line at the bottom. Not the bottom of the protractor, but the 0 line with your vertex. It's going to go right on there. I'm going to get as close as I can before it snaps up. And let's call that as close as I can get. Okay, so yours is right on that line. Mine is, it's just a smidge off, but it'll do. I'm going to look at my lowest number of degrees. It's easier to work from lowest to highest. I can see that my lowest is 61. 61 degrees is for baseball and soccer. They are both 61 degrees. So let's do baseball first. Let's do baseball. So I'm at my 0, and I'm going to count up from 0. Make sure I don't start at 180. I'm going to count up from 0 all the way to 61. So 0, 10, 20, 30, 40, 50, 60, and I will go 1 more degree, and I will draw a line at 61 degrees. 61 degrees. Perfect. I'm going to get my protractor. Oh, and it's doing the same thing. See, this is why we don't do math on a computer, because it's not ideal. Not ideal at all. I'm going to draw my line, my little nick on here, aligning with 61 degrees. Perfect, right up there, and hopefully it doesn't move it away. Perfect. I am going to take a ruler, or the bottom of my protractor works just as well, and I am going to draw a line from that nick all the way in. There we go. So, if I were to measure this angle, it would be 61 degrees, and I know that 61 degrees is our reading for baseball. It also happens to be our reading for soccer. Let's do baseball first. That's what we said we were doing. Before I forget what I have done here, I'm going to label it baseball. Baseball. Here we go. Perfect. Okay. Now I am going to continue. I'll delete this stuff up here. Doesn't want me to delete that line. That's okay. What are you going to do? Nothing's going right today. We've got another 61 degrees. So I'm not going to take my protractor and realign it with that. I'm going to align it with my new line where I left off before. So I'm actually going to rotate my protractor. Rotate my protractor so that the 0 is right on my new line. This will be easier for you because you're actually working with your hands. I'm working with a computer that doesn't exactly want to cooperate, but look at that. I got it right on the 0, so at least there's that. And once more, I did baseball. I'm going to look. My next sport, soccer, 61 degrees. Let's take a look over. I'm going to count up from that 0 line. I start at 0, 10, 20, 30, 40, 50, 60, 61. It's going to be up here. I'm just getting out of the way so that it doesn't think I'm trying to draw on the protractor. And look at that, it does. Of course it does. Why wouldn't it? Let's try to get completely out of the way so that when I move my protractor away, it doesn't think that I'm drawing on it. How big is my protractor's box? Oh, That's pretty big. Yeah, don't work on computers, guys. This is why we do all of our math work on paper. This is going to frustrate me to no end. Is that high enough for you, computer? Let's see. Let's see. There we go. Okay, so I've moved my protractor away, and I am going to draw my line using a ruler. We remember it is 61 degrees. I measured it on my protractor. Goes all the way up. There we go. Right to the edge. And before I forget what it is, 61 degrees, our second one, aligned with soccer. We've already done baseball, so there is 61 degrees for soccer. I'm going to write that in there. Soccer. SOCCER. Now remember, we are going lowest degrees to highest. We did our 61s. Next is a 72. 72 is our number of degrees that aligns with football. So 20% of students that we surveyed liked football best. That we found out was 72 degrees on our circle. So we're going to grab our protractor. We're going to bring it over, and we're not going to use the same circle or the same vertex, the same angle as the last one we used. We are going to rotate it to where we left off, to the end of our last one. We're going to make sure that 0 aligns as perfect as I can get it on the computer. And you working in person, well, you don't have all this crazy stuff going on. You can do it perfectly, perfectly, perfectly aligned. I'm going to get us, oh, look at that. That's pretty good. So, football, 72 degrees. 72 degrees. I am going to count up from 0, 10, 20, 30, 40, 50, 60, 70, and then 1, 2 degrees. It's going to be out here, and I'm going to give myself as many little dots as I can. You don't have to. You can just put a nick right there, but I know my computer is going to think that I'm drawing on that protractor, and when I move it away, I'm going to lose my drawing. So, am I going to be so lucky? Aha! At least my plan worked. Okay, good. I've got this nick here. I'm going to use a ruler. I'm going to draw from my vertex out towards that marking that represents 72 degrees. There it is. 72 degrees, we remember, was for football. So I'm going to label this section football. Football. Okay, and now we are left. We have done our 61 degrees. We've done our second 61 degrees. We've done our 72 degrees. We're just left with this 169. You could say, well, aren't we left with this 360? But no, 360 actually just represents the total. The whole circle is 360, so we never had to represent that. We're just left with this 169 here. And because it's the only one left, this is why we worked from smallest to largest. It's the only one left, so we don't actually have to measure anything. It's the last piece of pie left. It's the biggest one. That's our hockey. That's our 47%, which, just we know colloquially, 47% is almost half. 50% would be half. And look at that. Our hockey represents almost half, just shy of half. So we're going to label it. And there we go. Now, if I were working on paper in person, I would start tidying this up. I would change this line so that it didn't go all the way out. I would delete this little guy. I would get rid of this stuff. Just tidy up, make it look nice. And then every chart, every graph needs what? Needs a title. Because we need to know what we're looking at when we're looking at this chart. So because this was students' favorite sports picked out of 4, I might just call it students' favorite sports. And there we are. We have made a pie chart based on our data.
I will just take you through a process. We started off with our real data. We surveyed a class what their favorite sport out of these four was. We listed all of those numbers. 14 people liked hockey, 6 liked football, 5 liked soccer, 5 liked baseball. We didn't forget to list our total. Always have to list our total at the bottom. We turned that data into percentages. So 14 out of 30 students liked hockey. What percentage was that? We did 14 divided by 30 times 100. Numerator divided by denominator times 100 gave us the percentage, 47%. We did that for all of our data, which gave us the percent, the proportion of the whole, and we used that to find our degrees. We knew that 100% of a circle was 360 degrees, so we just found these percentages of 360. What was 47% of 360? Well, we multiplied 360 times the decimal version of 47%. 360 times 0.47 equals 169. We did that for all of our degrees, and that enabled us to begin on our actual chart, where we used a protractor and the degrees that we found just to start with one line, measure out our degrees, draw the second line, and then we moved our protractor to align with that line, measured our degrees, drew a new line, and we moved our protractor, always working with the new line, until there wasn't anything left to do. You can see at a glance, our class liked hockey best, but there's a respectable amount of interest in the other 3 sports, which is the nice thing about pie charts. You're able to interpret them right away, pretty instantly. They're a little bit of work, but for representing proportions of a whole, they really can't be beat. They're probably the best chart for that. So now you know how to do a pie chart. Thank you for watching almost 30 minutes of this. I hope it was helpful. I hope it's helped you study for your test. Give it a go on your own. See if you can do this. Good luck. I know you can do it.